assuming things go well, we'll 10x that output next year. So we'll aim to do maybe 50 to 100,000 humanoid robots next year.
For the first time, Tesla is building a gigafactory not for cars, but for humanoid robots. No shared production lines, no reused infrastructure. Optimus will have its own dedicated manufacturing empire. This decision shows that Elon Musk doesn't see the Tesla bot as a side project, but as a core strategic product. So what makes Tesla need an entirely new factory just to build robots? Before we begin, please help us reach 12,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla bot, Tesla EVs, and the latest news. How will the new factory optimize mass production specifically for Tesla bot? Tesla is preparing for a revolutionary leap in the robotics industry with its decision to build a dedicated gigafactory for producing the Tesla bot, Optimus Gen 3. This isn't just another ordinary factory. It's an expansion of the Giga philosophy that Elon Musk has successfully applied in the electric vehicle industry. Just as Giga Texas and Giga Shanghai once set records for Model Y production speed and scale, Giga Tesla Bot will be the facility where the goal of manufacturing millions of humanoid robots per year becomes reality, with low costs and high customizability. Unlike today's robotics factories, which mostly rely on manual assembly and produce in very limited volumes, Tesla is gigafying the entire Optimus production process by vertically integrating every stage, from raw materials, machining, and assembly to final testing, all within a single facility. This vertically integrated model, already proven in Tesla's vehicle production, allows for tight control over every step, reduced dependence on outside suppliers, and a streamlined environment where AI can continuously learn and improve right inside the production loop. Beyond factory layout, Tesla's design thinking is embedded in every technical detail of Optimus Gen 3. The robot has been built for mass production from day one, a drivetrain composed of just 5 core components, modular hands with 11 degrees of freedom that can be assembled by machine, and a custom-designed chip developed in-house, not sourced externally. This simplification doesn't mean reduced performance. On the contrary, Optimus Gen 3 can operate continuously for 10 hours per charge and recharge in just about 10 minutes. These are breakthrough figures, far beyond what current prototypes from Figure AI or Agility Robotics can achieve, most of which are still stuck in small-scale trials. What's remarkable is that Tesla isn't just building robots, it's enabling robots to build robots. In recent demo videos, Elon Musk showcased Optimus independently stacking trays, assembling modules, and moving around the factory floor. When Giga Tesla Bot is fully operational, Optimus robots will be actively involved in assembling future generations of themselves. This creates a unique closed-loop system. Data collected from thousands of robots will be fed back into the factory to improve both hardware and software, which will be immediately applied to the next production batches. Here, automation isn't just a tool, it's the DNA of the entire system. Another key factor that makes the Giga strategy so effective is the economy of scale. Once output reaches hundreds of thousands or even millions of units annually, the production cost per robot will drop significantly. Just like Tesla once cut the price of the Model 3 from over $50,000 to around $35,000 within a few years. Elon Musk has stated he wants the Tesla bot to cost under $20,000, while the first version may be priced higher, around $30,000 to $40,000. With current improvements in manufacturing, mass affordability is not far off. According to internal data in 2025, Tesla plans to start production at Giga Tesla Bot by the end of 2026, with an initial output of about 250,000 units per year, scaling up to 500,000 units by 2028. This is unprecedented in the humanoid robot industry, where companies like Boston Dynamics and Figure AI are still hand-assembling a few hundred units per year. The ability to produce one robot every 30 seconds, as Elon Musk mentioned during Investor Day, illustrates that Giga Tesla Bot is more than a factory. It's a global-scale robot-making machine. Equally important is Tesla's strict application of the design for automation principle. Every part of Optimus is standardized for easy assembly, replacement, and repair. Quality control systems are embedded with sensors, cameras, and AI software, eliminating the need for manual inspection. This not only cuts labor costs but also boosts production speed and reduces the risk of product defects, both critical if Tesla aims to reach the ambitious goal of 1 million robots per year. In short, Giga Tesla Bot represents a major leap in turning humanoid robots from high-end research prototypes into mainstream consumer products, ready to work in factories, offices, hospitals, and even homes. It reflects not just an industrial vision, but Elon Musk's preparation for a global infrastructure that will support a post-labor era where robots take over most of the basic human tasks. In the not-so-distant future, the Tesla Bot may become the iPhone of robotics, and Giga Tesla Bot is the massive Foxconn-style engine behind it. Once again, please help us reach 12,000 subscribers. This is important for us to stay motivated. Thank you. What will Tesla do to scale up and reach the goal of producing millions of units per year? When Elon Musk announced that Tesla would produce millions of Optimus humanoid robots per year, many considered it an overly ambitious goal. But looking back at Tesla's history, from a startup producing just a few thousand Model S cars annually to nearly 2 million Model Y and Model 3 vehicles in 2024, it's clear that Tesla has already achieved what once seemed impossible. Now, the target of producing 1 million Tesla bots per year is not just a milestone in scale, but a stepping stone to bring humanoid robots out of research labs and into everyday life, turning expensive prototypes into globally accessible consumer products. As of mid-2025, Tesla is believed to have completed trial production of about 10,000 units of the Optimus Gen 3 in the US, primarily for internal use in the Cybertruck production line and select enterprise partners. However, according to Musk's roadmap, released earlier this year, Tesla aims to reach an output of 100,000 to 250,000 robots per year by the end of 2026 and scale to 1 million robots annually before 2030. To achieve this, Tesla likely won't rely on a single factory. The first Giga Tesla Bot facility is expected to be located near Giga, Texas or Giga, Nevada. But Musk has hinted at the possibility of additional plants in Europe and Asia, with potential sites including Berlin and India. If each factory can produce 250,000 robots annually, Tesla would only need 4 such plants to hit the 1 million unit mark, a figure unprecedented in the humanoid robotics industry. This expansion strategy doesn't rely solely on building more factories. It's also driven by Tesla's ability to share components with its EV business. Tesla is reusing the 4680 battery cell, compact electric drive units, FSD chips, and even OTA software, all of which were originally developed for electric vehicles. This dramatically reduces production costs and accelerates deployment. Analysts estimate that the current production cost per Optimus unit ranges from $80,000 to $100,000. But once output exceeds 500,000 units per year, that figure could drop below $20,000. Thanks to such economies of scale, Tesla may realistically deliver on its goal of an affordable robot for the masses, just as it once did with the Model 3. Equally important, mass production on the scale of millions of units per year enables Tesla to build a collective learning network for its robots. Every Tesla bot operating in the real world continuously sends data back to Tesla's AI training center. Through a system of continuous learning and synchronized OTA software updates, Tesla can improve its entire global robot fleet with a single update. This is a decisive advantage that rivals like Figure AI, Boston Dynamics, and Agility Robotics, each deploying only a few hundred units, simply cannot match. Economically, producing 1 million Tesla bots per year could represent a major shift in the global labor market. If each robot can replace the work of a general laborer earning an average of $30,000 per year, then the Optimus fleet could generate the equivalent of $30 billion in value annually for businesses worldwide. This doesn't even include specialized applications in healthcare, elder care, industrial manufacturing, logistics, and even space operations. How will the structure of this future bot factory differ from Tesla's existing gigafactories? If Tesla's current gigafactories were built to optimize electric vehicle production, from chassis to drivetrain to battery systems, then the future Giga Tesla bot must be completely redesigned. This is because the product it will manufacture is no longer a four-wheeled machine for the road. but a humanoid robot capable of navigating complex environments. This shift demands a fundamental change in the factory structure, processes, and operational philosophy. In other words, Giga Tesla Bot will be a next-generation Giga, where robots build robots, and assembly lines are no longer tailored for heavy, rigid objects, but for mobile, intelligent entities that can learn over time. First, the assembly line at Giga Tesla Bot will move from a linear process to a modular cell-based model, similar to how Lego systems work. While EV factories often rely on long conveyor belts, where vehicle frames move sequentially through stations, building Optimus, with its human-like structure, requires the process to be divided into modular clusters, arms, legs, torso, head, and drivetrain. Each module will be assembled separately in highly automated stations and then integrated during the final stage. This approach reduces production time per robot to just tens of seconds and allows for easier expansion, maintenance, and upgrades of individual parts without disrupting the whole line. What's more impressive is that Optimus itself will be part of the process. In Tesla's latest demo videos, the robot is shown navigating factory floors, manipulating materials with precision, and even assembling basic components of another robot. With such capabilities, the future factory will include zones where humans are not required, where robots collaborate with other robots in a fully AI-controlled environment. This marks a core difference from Tesla's existing Giga Factories, which still rely on thousands of engineers and workers for operation. Another unique feature of the Tesla Bot factory is the integration of AI training systems and data centers directly on-site. In current Giga Factories, data from vehicles is sent back to Tesla headquarters or the Dojo supercomputer for processing, training, and software updates. But with robots, where every action is a real-world interaction, data needs to be processed, trained, and updated in real time. That's why in Giga Tesla Bot, clusters of Dojo supercomputers will be located right next to the production lines, continuously learning from active robots and instantly updating the behavior of new units being built. This creates a closed loop of learning, production, and improvement, all in real time. Additionally, the architecture of this new Giga will prioritize vertical flexibility and space optimization, unlike the sprawling layout of current EV plants. Since robots are far lighter than cars and don't require wide transport areas, Tesla can build vertically stacked assembly tiers, maximizing factory space and minimizing land usage, an essential consideration as Tesla expands into countries with limited industrial land, such as Japan, South Korea, or the Netherlands. One lesser-known but critically important innovation is the autonomous quality inspection system. At Giga Tesla Bot, quality checks will no longer rely on human inspectors. Instead, robots will test each other using built-in sensors and AI-driven diagnostics. An Optimus, once fully assembled, could test another Optimus's arm movement, force sensors, and visual systems, all through procedures conducted by its robotic counterpart. This is the pinnacle of automated quality control, where the product becomes the most precise inspector of its own kind. What truly sets the Tesla Bot factory apart is its stark contrast with how competitors are approaching humanoid robot production. For example, Figure AI, one of the most closely watched startups, is still assembling its Figure 01 robots semi-manually in a lab-like setting, with only a few hundred units planned for 2025. Their lines heavily depend on engineers and specialists working through each step, with no scalable infrastructure in place to handle thousands of units per month. When most robots freeze in sub-zero conditions, Tesla Bot stays active. Its cold-resistant LFP battery works even at -20 degrees Celsius without external heating. From Nordic warehouses to icy docks, Optimus is built for real-world extremes. What makes Tesla Bot thrive where others shut down? Before we begin, please help us reach 12,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. How can Tesla Bot work in freezing environments? The ability of the Tesla Bot to operate reliably in cold environments, such as Northern Europe or sub-zero warehouses, is becoming more feasible than ever, thanks to major advancements in battery technology, particularly Tesla's adoption of cold-resistant LFP, lithium iron phosphate batteries. While most attention is currently focused on Optimus's mobility, hand control, or artificial intelligence, the battery remains the critical factor that enables the robot to function effectively outside the lab. In real-world industrial environments, especially in Nordic countries during winter, temperatures can drop to -10 to -25 degrees Celsius, severely degrading the performance of conventional lithium-ion batteries. The chemical reaction rate inside the battery slows down, discharge current weakens, voltage drops, and the operating time is significantly shorter than the original design. For a humanoid robot like Optimus, where every movement, sensor, and processing task depends on the battery, any drop in energy supply can cause balance issues, delayed responses, or complete shutdown. In this context, the new generation of LFP batteries has emerged as an effective solution, especially as suppliers like CATL have developed versions of LFP cells that can operate stably at -20 degrees Celsius without the need for external heating systems. By improving electrolytes, applying nanocoatings to the cathode surface, and even integrating mild self-heating mechanisms, these batteries can maintain high performance in harsh conditions while still achieving 3,000 to 5,000 charge cycles. Tesla has already deployed LFP cells in standard versions of its Model 3 and Model Y, and it's highly likely that this technology is being specially refined for Optimus Gen 3, a robot Elon Musk describes as a mass-produced product optimized for cost, safety, and energy efficiency. Tesla's decision to use LFP instead of higher energy density chemistries like NMC is also deliberate. A humanoid robot doesn't need to travel hundreds of kilometers like an EV. It needs stability, safety, lightweight design, and good thermal tolerance. LFP perfectly matches these criteria. It's non-flammable, highly resistant to explosion from impact, generates less heat, and costs significantly less to produce. For robots operating in environments prone to collision, slippery surfaces, or working closely with humans, such as hospitals, warehouses, or factories, these safety attributes are critical. Due to its thermal stability, Tesla can also avoid installing complex cooling systems, allowing for a compact, simple design that's easier to mass-produce, fully aligned with Elon Musk's mass production-first philosophy for Optimus. Equipped with cold-resistant LFP batteries, the Tesla bot could operate in cold storage facilities in Sweden, logistics hubs in Finland, or even outdoors in Norway during winter. Unlike current robots on the market, like Boston Dynamics Atlas or Agility Robotics Digit, that often require room temperature conditions to function properly, Optimus aims to be a universal robot, working wherever humans work, regardless of climate. This is a key strategic differentiator. It also opens up a massive, untapped market. Frozen food logistics, pharmaceutical cold storage, or cargo processing centers in cold regions are all in urgent need of automation solutions that can operate continuously. If Tesla becomes the first company to commercialize a humanoid robot that can work 8 to 10 hours a day at -10 degrees Celsius without needing a heating system, it will dominate a segment that competitors have yet to reach. This advantage becomes even more significant as Tesla can leverage its own European factories, like Giga Berlin, to deploy Optimus internally before expanding to partner companies across Northern Europe. While many other robotics firms are still testing their robots in lab-controlled environments, Tesla is already one step ahead, turning its robot into a real-world worker, efficient, energy-saving, cold-resistant, and ready to scale. From a strategic standpoint, adopting cold-tolerant LFP batteries is not just a technical choice, but the foundation for global market expansion, especially into regions that were once considered off-limits for humanoid robots. Once again, please help us reach 12,000 subscribers. This is important for us to stay motivated. Thank you. What does the M3P battery improve in Optimus design? Beyond the cold resistance of LFP batteries, another breakthrough that allows Tesla to optimize the design of the Optimus bot, the application of M3P batteries, a new technology that incorporates manganese into the phosphate battery chemistry. The addition of manganese significantly improves the energy density compared to traditional LFP cells, while retaining key advantages such as stability, low cost, and long lifespan. For a humanoid robot like Optimus, this isn't just a minor battery improvement. It's a leap that could transform the entire internal architecture of the robot. One of the biggest challenges in humanoid robotics is integrating a powerful battery without consuming too much internal space or adding excess weight. Every component inside Optimus, from the drivetrain in the arms and legs to the AI boards, sensor clusters, cameras, and signal processors, requires both energy and room. If the battery is too large, it would take up valuable space within the robot's torso, forcing Tesla to compromise on flexibility or performance. But with M3P cells, which offer 15 to 20% higher energy density than LFP, Tesla can maintain the same energy capacity in a significantly smaller form factor, or extend operational time for several additional hours without enlarging the body. This opens up internal space within Optimus to integrate other essential modules, such as the neural net processing system, additional actuators, or even a passive cooling system. Notably, with the modular design approach revealed by Elon Musk in Gen 3, the ability to restructure battery placement provides ideal conditions for building a flexible hardware architecture, allowing components to be easily upgraded or replaced without redesigning the entire robot chassis. For instance, if the battery takes up less volume, the torso or back of the robot can be optimized to add proximity sensors, wireless receivers, or specialized ports for different versions. Optimus Care might need heart rate monitors, while Optimus Pro for factories could include temperature, vibration, or humidity sensors. M3P doesn't just impact internal layout, it also greatly influences weight and motion mechanics. A lighter battery means a lighter robot, which reduces strain on joints, motors, and the drivetrain system. This not only increases the mechanical longevity of Optimus, but also saves considerable energy during movement, especially as Tesla aims for ultra-efficient actuators to deliver 8 to 10 hours of operation on a single charge. Moreover, the reduced battery weight improves balance and allows the robot to shift its center of gravity more easily when walking over uneven terrain or lifting heavy objects. Another interesting benefit of M3P cells is improved heat distribution. Thanks to their higher energy density, Tesla can arrange the batteries in smaller clusters distributed evenly across the robot's body, rather than concentrating them in one spot like the abdomen or chest. This spatial distribution reduces thermal hotspots, a common issue with lithium batteries, and allows passive cooling meshes to work more effectively, preventing overheating during prolonged operations. From a manufacturing perspective, standardizing M3P battery modules also gives Tesla a major advantage. Because Tesla produces its own batteries, it can customize module sizes for each robot version without depending on third-party suppliers. This lowers costs, speeds up assembly, and supports large-scale deployment across Giga Factories. If Optimus can share battery modules with other Tesla products, such as Powerwall or even the Cybertruck, the unit cost will drop significantly, supporting Tesla's target to bring robot prices below $20,000. More importantly, with M3P batteries, Tesla is getting closer to the ideal balance of form, performance, and price. A smaller battery not only makes Optimus more compact and human-like in form, but also allows it to navigate tight spaces and operate in offices, homes, or hospitals, places where size, weight, and graceful movement matter. A robot that is too large or heavy would struggle to be accepted in living spaces, but if Optimus can be light, efficient, and visually friendly, its commercial potential expands well beyond industry into everyday life. Therefore, Tesla's research and application of M3P in Optimus isn't just a technical battery upgrade, it forms the backbone of a long-term product strategy, from optimized design and scalable manufacturing to energy savings and everyday usability. In the world of humanoid robotics, where every millimeter of space and every gram of weight matters, a smaller, more durable, and smarter battery could be the key that helps Tesla outpace rivals like Figure AI and Agility Robotics. How could Tesla charge robots as fast as EVs? If electric vehicles can rely on a global supercharger network for fast charging and seamless travel, there's no reason Tesla wouldn't develop a similar infrastructure for the Tesla bot, especially as Elon Musk pushes toward the commercialization of millions of humanoid robots worldwide. With the goal of making Optimus an efficient replacement workforce in factories, warehouses, hospitals, and even in homes, fast, flexible, and autonomous charging becomes essential to ensure 24/7 operation. Tesla cannot depend on outdated methods like removing the battery to charge or manual plug-ins as with today's standard robots. Instead, building a dedicated robot charging ecosystem, a super-fast robot charging network, will be a key element enabling Tesla to deploy Optimus at scale, just like how the supercharger network propelled Tesla EVs from a niche product to a global force. Following Tesla's design philosophy of minimalism and automation, robot charging stations would likely eliminate bulky cables and adopt contact-based or wireless docking methods. Similar to how today's robot vacuums autonomously return to their docks when low on battery, Optimus could be programmed to find the nearest charging dock using internal maps or indoor navigation systems. Each robot charging station could integrate AI-powered identification, silent interfaces, and deliver moderate yet fast enough power to fully charge the robot in under 15 minutes. Elon Musk previously claimed Optimus charging would be extremely fast, and this is entirely feasible if Tesla repurposes existing EV technologies, such as active cooling during charging, high-rate charge-discharge batteries, and real-time charging algorithms. Unlike EVs, robots don't need outdoor stations or high-voltage infrastructure. Robot charging networks could be embedded directly within factories, logistics hubs, hospitals, or offices, the same places where robots work. This allows Tesla to build compact charging modules that mount to walls or integrate into floors, using standard AC power or internal low-voltage DC systems. If Tesla develops its own charging standard for Optimus, similar to the NACS port used in its vehicles, it could rapidly scale without being limited by slow-to-evolve industrial norms. Strategically, this would mean Tesla not only sells robots, but also the supporting charging infrastructure, creating a closed ecosystem and increasing enterprise customer retention. With Elon Musk's long-term vision, it's entirely possible that future robot charging stations won't just recharge batteries. They could be designed as mini maintenance hubs. When the robot docks, the system could automatically update software, run diagnostics on sensors, upload learning data to central AI servers, and even perform quick performance checks. This would transform each charging dock into a smart service hub, helping Tesla bots remain in optimal working condition without human intervention. Through wireless communication, robots in the same facility could even share charging statuses, suggest available docks to each other, or prioritize queues based on urgency, a concept first seen with robo-taxi fleets, now applicable to industrial robot ecosystems. This kind of robot charging network would be especially valuable in high-demand, continuous operation environments. For instance, in a warehouse running 3 shifts per day, Optimus could work 6 to 8 hours, return to dock for a 10-minute charge, and go right back to work without any downtime or crew changes. With such an optimized system, a team of 10 robots could replace more than 30 human workers while maintaining non-stop efficiency. High uptime, a critical metric for enterprises, would be guaranteed. From an investment perspective, this gives Tesla a major edge when pitching Optimus to large-scale clients like Amazon, DHL, Walmart, or major hospitals seeking automation. The future of the robot charging network isn't limited to factories or warehouses. Once Optimus enters the consumer market, assisting at home, helping the elderly, supporting people with disabilities, fast and convenient charging will become even more critical. Instead of large industrial stations, Tesla could introduce home Optimus chargers, sleek, quiet mini-docks designed to blend with smart home interiors, fully integrated with Tesla home systems or the Tesla app. Charging a robot would become as familiar as charging a phone or EV, bringing Tesla closer to the vision of a fully integrated smart home, from solar panels, power walls, and EVs to humanoid robots. Looking at the bigger picture, developing a super-fast robot charging network is not just a technical requirement. It is a strategic foundation to make the vision of 1 million Optimus units working daily a reality. Just as the supercharger network enabled Tesla EVs to go mainstream, we appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.